Hello everyone, welcome back to Prep Pro Papers. We were solving for GS 2023 TIFR JGEEBILS paper. We are beginning with part 3 of that series for the chemistry section. So let's get started. The first question says the structure of nitrous oxide N2O can best be described by a resonance of two structures. The hybridization of nitrogen atoms in the two resonance structures are. So let's draw the two resonance structures of the nitrous oxide. The possible two structure for N2O nitrous oxide can be firstly N triple bond N single bond O with nitrogen with partial positive and oxygen with partial negative charge. Then N double bond N double bond O with one of the nitrogen with partial negative charge and another nitrogen atom with partial positive charge. So in the both of the cases, we are getting the sp hybridization of the nitrogen atoms. So the correct option is option number 1. So go to the next question. Which statement is true for the following chemical reaction? CuCO3 plus heat gives CuO plus CO2. Second is CuO plus SNO gives CO plus SNO2. So here we are getting for the copper right now is in +3 oxidation state. It is getting converted into +2 oxidation state. In the second equation, here the copper is in +2 oxidation state and Sn is in +2 oxidation state. It is getting converted into elemental form 0 and there SNS +4. So we see that let's go with the we see that carbon dioxide's role is not there, that carbon dioxide is getting oxidized, which is not true here. And COCO3, let's check for the COCO3, which is getting oxidized wrong because COCO3 is getting reduced. We see that for SNO, it is getting from +2 oxidation state to +4 oxidation state, which is oxidation. And for CO, which is from +2 oxidation state getting to elemental form 0, is the reduction. So the correct option is option number 4. Let's get to another question. Among the following, the one that gives positive iodoform test upon reaction with I2 and NaOH is. Okay, let's check for the options. Okay, let's first understand what iodoform test is. Iodoform test is a chemical reaction to identify the compounds which contains CH3CO group, that is a methyl ketone group, or can be oxidized to this group. When a compound reacts positively, it produces a yellow precipitate through the iodoform, which is CHI3, the yellow PPT. Compounds that can give positive iodoforms are methyl ketones, ethanol, and secondary alcohols that can be oxidized to a methyl ketone, and acetaldehyde because it contains a CH3CO group. So only there is one option which contains a CH3CO group, or this is a secondary alcohol containing group. Therefore, the correct option is option number second. Next question says dinitrogen tetroxide breaks down into nitrogen dioxide. If the reaction is reversible and endothermic, which condition will give the largest yield of NO2? So the question says that dinitrogen tetroxide gets converted to dinit converted into nitrogen dioxide, and this reaction is reversible and endothermic. So we know for the endothermic reaction, increasing temperature provides the energy for the reaction to proceed forward. So let's check for which option says high temperature. These two options is for the high temperature. We eliminate these two options. Now when we talk about the pressure, uh, a low pressure will favor the side with more moles of gas. So we see that the more more number of the gas is in the forward reaction, that is when nitrogen dioxide is getting produced. So the correct option is second. Let's go to the third question. The melting temperature of a human protein is 33 degrees centigrade. In 100 millimolar sodium phosphate buffer at pH 6.5, what should be the predominant conformation of the protein in the same buffer at physiological temperature conditions be? Let's check what are the physiological temperature. The physiological temperature is 37 degrees centigrade. So as the physiological temperature is greater than the melting temperature of the protein is likely to be getting denatured. So the conformation which we will be getting will be disordered. Let's check for the next question. 20 microliter of a 10 milligram per ml solution of protein A, molecular weight 10 kilodalton, is added to a 20 microliter of a 10 milligram per ml solution of protein B of molecular weight 20 kilodalton. What is the molar ratio of the proteins A and B in the mixture? Okay, we know that 1 kilodalton is equivalent to 1 gram per mole. This you need to be remember. This the conversions you should remember. So let's check for the what are the number of the moles of protein A, which can be 20 microliter, that is 20 into 10 to power 3. I'm converting this microliter for the ml conversion into 10 mg per ml is the concentration, that will be divided by for the mg unit divided by this much, as the molecular weight of the protein is 10 kilodalton. So will be 2 into 10 to the power minus 5. For protein B, it can be 10 to the power minus 3 into 10 divided by, okay, because we are converting milligram to the millimole gram thing also, so there will be 1 10 to the power minus 3 unit coming more, that will become 8 minus 10 into 10 to the power minus 3 again, and the weight is 20. Not kilo dalton, 1 dalton is equal to gram per mole, so kilo conversion is this much, will give to 1 to 10 to the power minus 5 So, sorry, 8. The ratio, molar ratio will be 2:1. Correct option is second option. Next is when the velocity of enzyme activity is plotted against substrate, the concentration which of the following is obtained. We know the Michaelis Menten equation, which says V is equal to V max into substrate concentration upon Km plus substrate value, and this is the hyperbolic curve. Let's move to the next question. Phosphoric acid is tribasic with 3 pKa values 2.14, 6.86 and 1 and 12.4 respectively. The ionic form of the acid that predominates at pH 3.2 is. So let's write all the three forms of the phosphoric acid. Firstly, it will get converted to the pK for this is 2.14. So we'll get further converted to pK for the second equation is 6.86 and for the third one is 12.4. The ionic form which we need to see which is probably dominant is at pH 3.2. So it will be lying between these two values, but 3.2. But we see that 3.2 is more closely to 2.14 rather than 6.84. So the predominant form which will be present will be of H2PO4 minus. Let's take further another question. If you have a polypeptide of size 11 kilodaltons, what would be the mass of the opening reading frame that codes for the polypeptide? The average mass of an amino acid and a nucleotide is considered to be 110 daltons and 330 daltons respectively. Okay, so let's see what are the given things. The polypeptide size is 11 kilodaltons, that is 11,000 daltons. Average mass of the polypeptide is 110 daltons. So the number of amino acids will be equal to 11,000 daltons divided by, this is the average mass of an amino acid. This for average mass of the amino acid, 10 daltons per amino acid which will be 100 amino acids. For number of nucleotides, will be, we got 100 amino acids multiplied by, you know that there are 3 nucleotides per amino 3 amino acid per nucleotides. It will be 300 nucleotides. Now the total mass will become, for 300 nucleotides multiply by 330 daltons are the weight for one nucleotide, which will be equal to 99,000 daltons. So uh, the correct option according to me should be this, but I don't know why this is given. If you got the answer for this question, please comment below and share with everyone else. We'll see. Let's go to the next question. Again, this is the repeated question. The answer was hyperbolic curve according to the Michaelis-Menten question. Select one of the below sets in which all the molecules shows a microwave rotational spectrum. So we know for the microwave rotational spectrum to be there requires a permanent dipole moment. So for H2, CH4 and CFS, there is, I'm writing permanent dipole moment PDM. No permanent dipole moment. HCl, CH3, Cl, CH2Cl and H2, all of these are having permanent dipole moment. For checking for the dipole moment, you can check the valence shells configuration, but these are the more prominently used molecules which are given in the option. So you should be remembering which of the four have the permanent dipole moment and which don't show the permanent dipole moment. Here in this H2 and CH4 are not having permanent dipole moment. In the illustration, SF6 is not having the permanent dipole moment. The correct option is option number B. To the next question. A tyrosine to the histidine mutation in the active site of an enzyme significantly affects its activity. The reaction is likely to be. Okay, so we know that tyrosine has a phenolic OH group, which can participate in hydrogen bonding and can act as an acid. Histidine has an imidazole side chain, which can act as both a proton donor or acceptor, giving it a role in acid-base catalysis. Given that the histidine is often involved in base catalysis due to its ability to more likely show proton acceptor, so this will be a free radical catalyst reaction. Let's go to the another question. If a branch polysaccharide amylopectin has 7 branching points, how many free OH ends are available for the reaction? If there are 7 branching points, there will be 7 OH ends available. Direct question. 7 is the answer. Okay, let's move to the next question. Michaelis-Menten equation can be represented as following. For an intracellular enzyme to function optimally, which of the following statements regarding the intracellular substrate concentration is true? Okay, if you see for the Michaelis-Menten equation, this being prominent in 2024 paper also, and is being prominent in 2023 question also. The in the I'm not going to read about all the options because this is again too direct and repetitive question in severance exam. The answer is the intercellular substrate concentration should be approximately same as that of the Km because Km is the intrinsic property of the enzyme protein. So There is no another use of reading through all the three options. The correct option will be option number 4. Okay, we are done with the general of the 2023 paper, the physics section, and the part 3 of the chemistry section. Part 4 for the biology section will be solving later. Stay tuned on the channel, and the exam is coming forward on 8th of the December. Hoping that you all are preparing well. Thank you. Bye.